Hey guys! For this video, we're going to be discussing how to solve an impulse problem. So let's go ahead and get started. I pushed my sister with a force of 10 newtons for 2 seconds. What is her change in momentum? And to solve this problem, I am going to go ahead and go through the guess method. So again, we're going to list out givens, write down our unknown, figure out what equation relates the given and unknown, substitute it in all of our numbers, and solve for our unknown. So let's go ahead and do that. For that, I'm going to go ahead and start by listing out my givens. So I know that I pushed my sister with a force of 10 newtons. So I'm going to say F is equal to 10 newtons. And I applied this force for a period of 2 seconds. And that is all that I know. I'm now ready to move on to my unknown. And my unknown here, guys, is not my momentum. It is my change in momentum, which is going to be equal to my impulse. And so just so you guys remember, impulse, we're going to depict using a J. So my unknown is impulse, J, which is equal to something. And to figure out what that something is, I'm going to use the equation that relates force, time, and impulse. So that equation is impulse, J, is equal to force times time. And now, this is really nice because my impulse is already by itself on one side of the equal sign, so I can move right on to my substitution step without doing any algebra. Substitution. And I can go ahead and substitute in my givens. And so I know that J is equal to force, which is 10 newtons, times time, which is 2 seconds. And I can go ahead and solve for my impulse. So I'm going to go to my solution stage, my solve stage, and you can again plug this in a calculator or solve it in your head. Either way, you will get that your impulse is 20 newton seconds. And remember, our impulse is equal to our change in momentum, which I'm going to say is delta P. And there you have it, guys. You have used the impulse momentum theorem to figure out what the change in momentum is for my sister. Now it's your turn. See if you can solve this on your own. Happy solving.